Hey guys, welcome to week 1 of quarantine notes for Trig. We're going to try this week. We'll see how it goes. If you hate it, let me know. If you love it, let me know. If you don't care less, let me know. If you don't let me know, I'm going to assume you didn't watch these. And I'm going to be really sad because look at this awesome Bitmoji I found for our welcome back screen. I'm just saying, look at that. It's perfect. I'm looking out a doggy door for the love. So, yeah, what I'm doing is I'm actually kind of going through our notes and picking out the stuff that we really need the most, and that's kind of how we're going to do this. So instead of me talking you through the actual whole chunk of notes, I'm pulling out the important stuff and I put it into this PowerPoint because it's a little easier for me to talk you through a PowerPoint than the notes itself. I can do the notes if that's what you would prefer, but we'll try this and we'll go from there. So here goes nothing. We actually have one little tiny bit of section 1.2 that we didn't get to before the world exploded and we all just had to stay home. So the last thing we need to talk about from 1.2 is solving right triangles, which is using our trig functions, the SOHCAHTOA stuff, to solve a right triangle. So it'll give you a right triangle and it'll give you some information. So our example that we have gives us the right angle. It has to give you that because you have to have a right triangle. And our example gives us the hypotenuse, 37.21, and a leg, 19.67. So in order to solve the right triangle, that means we need to find everything else, any missing sides and angles. So we need to find side A as well as angle alpha and angle beta. So the first thing we're going to do is the easy thing, which for us is going to be to find side A. We can do that with good old Pythagorean theorem. A squared plus 19.67 squared equals 37.21 squared. And you do your work, square those, subtract that 19.67 squared over, and then square root both sides, and A is about 31.59. No big deal. Pythagorean theorem. I have faith you can do that. It's the angles that are tricky to find because we know that this one's 90, but we don't know anything about alpha up here or beta over here. So you can do whichever one that you want first, but we're just going to go for alpha first here. So all we know, we don't want to use this A value we found because that's rounded. We want to be as exact as possible. So we know that this side here is 19.67. We know the hypotenuse is 37.21. So if we're looking at angle alpha, 19.67 is the adjacent side. 37.21 is the hypotenuse. So adjacent and hypotenuse go with cosine. So we can say the cosine of this angle that we don't know, alpha, equals 19.67 over 37.21. And so to get alpha by itself, we have to undo cosine. And it's not like division. It's not like saying cosine times alpha equals that stuff. So we just have to undo cosine with what's called inverse cosine. And if you look on your calculator, that's just second cosine. You'll see that cosine with that little -1 looking thing. That's what you do. You hit second cosine, type 19.67 over 37.21, and you should get 58.09. If you don't panic. Make sure that your calculator is in degrees. Because go to mode, it's the button up there by second, up on the top left, the second one in. Go to mode, and then go down to where it says radian and degree, and make sure that degree is the one that's kind of like colored black. Do that, and then type it in again, and that's what you should get. So then we need to find beta. So if we look at angle beta here, 19.67 is the opposite side of that. And we have hypotenuse. So the trig function that uses opposite and hypotenuse is sine. So we could say, okay, sine of beta equals 19.67 over 37.21. Just like before, if we want to find beta, we need to get rid of sine. So we use that inverse sine. So you hit second sine, type that stuff in, and there's your answer. But you could also just do 90 minus 58.09 because we know alpha plus beta have to add up to be 90 if that guy over here is 90. So either way, you should get 31.91. All right, so that's how you solve right triangles. If you have the angle, you're not going to use this inverse. If I know that angle alpha is 58 degrees, then I could say like cosine of 58 equals A over 37.21. And then I just multiply 37.21 over, and I can solve it that way. So that's another way you can solve stuff. If you have angles, you don't use the inverse. The only time you use this inverse cosine, inverse sine, inverse tangent is when you're finding angles. So with that, you should now be able to finish the 1112 homework on my math lab. Hopefully you stayed caught up on 1.1. And there are only a couple of problems that you need to do for 1.2. And so I went through and deleted a bunch. So if you just click through the homework, you'll see a bunch of them say this problem has been deleted by your instructor. And you'll just get like freebie points. Easy peasy. So if you go through and do like, I think there's 4 problems from 1.2 over solving triangles. Cool. So if you want to hit pause and go work on those, go for it. If you're just super excited to do some trig, we're going to keep on going and do some more stuff with Unit 1. We're going to talk about trig functions in the Cartesian plane. What happens when we're talking about trig functions on the graph? So typically we have a point, an xy point, and that creates a triangle in the plane. The x is how far we move to the left or right. The y is how far we move up or down. And the radius, the r value, is actually always the hypotenuse of your triangle. We have this angle theta that's always created by the terminal side of our angle and the x-axis. And so Pythagorean theorem is going to say x squared plus y squared equals r squared, which means r is always the square root of x squared plus y squared. And r is a distance, so r is always positive. X and y can be negative depending on where they're located on the graph, but r is always positive. So if you look at your angle theta here, opposite over hypotenuse is going to give me y over r. Cosine, adjacent over hypotenuse, cosine is always going to be x over r. Tangent would be opposite over adjacent. Tangent is always y over x. And then just like always, cosecant is sine flipped, secant is cosine flipped, and cotangent is tangent flipped. So this is going to be something that's going to help you out throughout the rest of trig, throughout calc. Lots of math stuff going on with this stuff. So why do we care? How are we going to use it? Let's look at an example. Our example says the terminal side of an angle theta in standard position passes through 2, 5. Calculate the 6 trig ratios for theta. So if you're a picture person, here's what that looks like as a picture. I've got this point, 2, 5, so it's over 2, up 5. My x value is 2, my y value is 5. And so I don't know what r is. So that's my first step, is going to be to find r. I do that by doing the square root of x squared plus y squared. So that's the square root of 2 squared plus 5 squared, which would be 4 plus 25. So my r value is the square root of 29. And from there, we're just plugging stuff in. So I have sine is y over r. Well, my y is 5. We just found r is square root of 29. So 5 over square root of 29, rationalize that, 5 square root of 29 over 29. Cosine is x over r, so x is 2, r is square root of 29, 2 over square root of 29, and then you rationalize. Tangent is y over x, so it's just 5 over 2. Then you do your flips upside down. Cosecant would just be sine flipped. So I would flip this 5 over square root of 29, and you get square root of 29 over 5. Cosine flipped upside down would be square root of 29 over 2. And then tangent flipped upside down is just 2/5. So it's really the same thing we were doing with our trig functions. You just have to find that r value first. Next example, exact same thing, just we have some negatives. Our point is -4, -7, and we want to find all 6 trig functions. So if you want a picture, we're over here in quadrant 3 now. Our x is -4, our y is -7. We need to find r. So -4 squared plus -7 squared would be +16 plus 49. That's 65. So r is the square root of 65. So y over r is -7 over square root of 65. Rationalize -7 square root of 65 over 65. Cosine x is -4 over square root of 65. Rationalize. Tangent y over x, which would be -7 over -4, which the negatives cancel, so you get +7/4. For your other 3 trig functions, you're just flipping. No big deal. Easy peasy. Okay. We also have what we call the quadrantal angles. These are the ones that aren't in a quadrant. So 0 degrees. If you look at your x, y, and r values for these, at 0 degrees, your x value can be anything, but your y value is always 0. So 0 over anything is 0. And you can kind of go from there. And so these just come in handy if you want to take a picture or a screenshot or jot these down in notes that you're taking. These are just ones that you kind of like to have handy. So that's a lot. So how do you remember what exactly is going on in what quadrant, where, who, what, when, why? If you think about the signs on points, in quadrant 1, everything is positive. X is positive, Y is positive, and like I said, R is always going to be positive. Over in quadrant 2, your X is negative, but your Y is positive. Quadrant 3, X and Y are both negative. Quadrant 4, X is positive, but Y is negative. So then if you say, okay, if I put X and Y together, what happens? So in quadrant 1, everything's positive, all 3 trig functions. Quadrant 2 is sine, quadrant 3 tangent is positive, and quadrant 4 cosine is positive. And all we're really worrying about here are sine, cosine, and tangent, because then their friends that we flip upside down are going to match. So we have this saying, all students take calculus, because in quadrant 1 it's all, quadrant 2 is sine, which starts with S, quadrant 3 is tangent, which starts with T, and quadrant 4 is cosine, which starts with C. It's kind of like a little mnemonic device to help you remember. All are positive, sine, tangent, and cosine. So why not do another example, right? So if the cosine of theta is -3/5 and theta lies in quadrant 3, how could we find the sine of theta? Well, if the cosine is -3/5, I know cosine is x over r. So that means that x is 3 and r is 5. But I know r is always positive, so the negative must go with the 3. So x is -3 and r is 5. And I can just use Pythagorean to find my y. -3 squared plus y squared equals 5 squared. Solve that out. and we get to y is 4. Okay, cool. Why do I care? Well, I know sine is y over r. So why does it tell me this quadrant 3 business? Because actually, when I got to this y squared equals 16 step, when I square root both sides, y could be 4, but it could also be -4. So what do I know about quadrant 3? In quadrant 3, y is negative. So actually my y is a -4. So sine is y over r. So it's going to be -4 over r, which I know is 5. Cool? Cool. All right, we have one more really big, super important, biggest thing of all you do in Trig thing to do. Oh yeah, there's me on a skateboard with a raccoon. Let's talk about the unit circle. The unit circle is cool. We started making this on your paper plate, and then we never got time to finish it. So the unit circle has a radius of 1. That's why we call it the unit circle. It has a radius of 1 unit. So that means its R value is 1. So we go through and we find all of these points. And you can do that with what you have in your notes already, because this first one is a 30-degree angle. And so you can find the sine and cosine for that. But sine is y, cosine's x, and tangent is y over x. And so it's like a point. So if you look in your notes for a 30-degree angle, we already found that sine is 1/2 and cosine square root of 3 over 2. 45, we looked and we said square root of 2 over 2 for both. For 60, we said sine was square root of 3 over 2 and cosine was 1/2. And we did those quadrantal angles. You should have those from 2 slides ago. And it goes all the way around the circle. And it looks really confusing and like a bunch of gibberish to you right now. But let me show you something cool. This first point here is 1, 0, because if I go out on the x-axis 1 unit, then that point is over 1 up 0. 1 is the same thing as the square root of 4 over 2. Take a minute, make sure that you believe me. The square root of 4 is 2 divided by 2 is 1. Square root of 4 over 2. Then we count down. Square root of 4 over 2, square root of 3 over 2, square root of 2 over 2. Square root of 1 is 1 over 2 is 0. And then we work backwards. 1, 3, 2, 1, 0. And then you just keep going around the circle that way. In the y spot, I have 1, 3, 2, 1, 0. 1, 3, 2, 1, 0. And it just keeps going around the circle like that. Put your positives and negatives where they belong. Over here, we have negative x's. Down here in quadrant 3, everything's negative. Over here, my y's are negative. Why do we care? Because if you have a unit circle filled out like this, I can say, okay, what is the sine of 135 degrees? Sine is y. So you go to the y value of 135 degrees. It's the square root of 2 over 2. If I say, what is the cosine of 5 pi over 3? You go to 5 pi over 3. Cosine is x. It's 1/2. If I say, what is the tangent of 5 pi over 4? You go to 5 pi over 4. Tangent is y over x. Well, those are the same thing. Anything over itself is 1. So its tangent is 1. So that's how the unit circle works. Sine is y, cosine's x, tangent is y over x. So you have some homework. There's an assignment on my math lab that just says week 1 homework. Week 1 of quarantine. I don't know what you want. Week 1. Week 1 just means week 1 of online homework. Next week, we're going to do the Unit 1 test, and I will have a review ready for you then. It's been a week for me. It's been a weekend. I'm going through it, but I will have a review ready for you at the end of this week so you can be ready for the test. The test will be on my math lab. You'll be fine. It's not over anything you haven't seen on your homework. So if you can do the homework, you can do the test. Email me, shoot me whatever questions you have. Let me know what you need help with. If we need to do like some little office hours and work through your homework, I'm totally down with that. We can set up a Google Hangout. We're getting Zoom set up. We can Zoom, we'll video chat, whatever you need. I am here to help. Let me know and we will get through this. Good luck. Holler at me. You've got this.